every day, your digital world, it's just humming with activity, isn't it? Routers, switches, access points. I mean, they're all constantly generating data. Health, status, every little event happening across your network.
It's a huge amount of information.
Exactly. It's this vast, complex ecosystem. But for you, the person trying to keep it all running smoothly, securely, how do you actually keep tabs on it all without just drowning? How do you know what's happening where and, when? Okay, let's unpack this.
Well, that's precisely where the Simple Network Management Protocol, SNMP, steps in. It really is the unsung hero, isn't it? Quietly working away, being the eyes and ears for your whole network infrastructure.
Like eyes and ears, I like that.
Yeah, it's like the universal language that
Yeah.
lets you understand what's going on right now across maybe thousands of devices, all from one place.
So our mission today is really to demystify SNMP. We're going to dig into its core functions, look at how its security has evolved, from the early days to the more robust stuff we have now. And crucially, how it helps you, managing the network, stay not just informed, but actually secure.
Right.
And we're drawing our insights from practical configuration guides, so this should give us a really hands-on view.
Definitely. And at its heart, SNMP is, well, it's a set of protocols for managing these complex networks. Think of it as a standard way for all your gear to report in.
Okay.
You've got your SNMP-compliant devices, switches, routers, firewalls, whatever, each running a little bit of software called an agent.
An agent, right.
And these agents, they collect and store key operational data in what are called management information bases, or MIBs.
It might be. Got
And
it.
you have your SNMP requesters, that's your management station, that ask these agents for specific data. They use these things called protocol data units, PDUs, to make the request.
So for you listening, managing your network, you could think of it almost like a smart sensor system.
That's a great analogy.
Yeah, constantly collecting, reporting on health, performance, any weird stuff, all in a structured way that your main management system can understand and maybe even act on.
Exactly.
Yeah.
It's surprisingly powerful when you get down to it.
Okay, so let's start at the foundations. SNMP basics. It's not just about getting the data, but crucially, how you control who gets to ask for it, protecting that management interface itself. What are the sort of first lines of defense?
That's a really important point, because when an SNMP request first hits a device, say a Ruckus switch from our guides, there are immediate checks, foundational security, your first level, really.
Okay.
You can use the command-like management access for broad restrictions, or you can get more specific, limiting SNMP access to certain MC addresses or IP addresses, only known machines allowed.
That makes sense.
Or for tighter segmentation, maybe restrict it to just one VLAN. And of course, the simplest way, if you don't need it, just disable it completely. No SIM server. These controls, they're like the bouncer at the door deciding who even gets to knock.
Right, okay.
Yeah.
But what's the default? On many devices, like those RHOS ones, is it on or off out of the box? Because if it's on, well, that could be a blind spot, couldn't it?
It absolutely can be. And yes,
Great.
on many devices, including RHUSA, SNMP, anonymity by default.
Ah.
So you as the network manager, you really need to be proactive,
Yeah.
intentional about your security. If you need to disable it, like I said, no SANC server. To turn it back on, just SIM server.
And to check.
A quick show SIM server tells you the status. This default on or state really underlines why those basic access controls we just talked about are so vital. They're your first safety net.
Yeah, even at this basic level, you're already seeing how critical that granular control is for security. It's not a free-for-all. You've got to be specific.
Right.
Or you might leave a door wide open.
Precisely.
Okay, now here's where SNMP security, well, the story gets really interesting. Community strings. They were the original way, right? But they had limitations. As networks got bigger, threats evolved. How did that security model have to adapt?
You're absolutely right. Community strings were the start for SNMP v1 and v2. Think of them as very simple password-like things for authentication.
Like public or private?
Often, yeah. You typically have a read-only string, sometimes allowing a station to just retrieve data, and then a read-write string, maybe public or something less obvious, hopefully, that allowed getting data and changing settings.
Okay.
But here's a really critical detail from the guides we looked at. While these strings get encrypted automatically when you see them in the command line interface, if you're using the web management interface, those read-write strings might actually be shown in clear text.
Wow, okay. That's significant.
It is. It's a big difference depending on how you're managing the device. Highlights a potential risk. Now, encryption for the strings is usually on by default, but it could be turned off. And you could also tie these strings to specific views, like sysview, to limit what part of the MIB they could even access.
That clear text thing is definitely an eye-opener. So what about brute forcing? What happens when someone or some script just keeps trying to guess these strings over and over, flooding your network with failed attempts? Doesn't that create its own problem?
Oh, absolutely. That's a classic issue. It can fill up your logs with noise, making it impossible to see real problems, and can even hit device performance.
Right.
I remember dealing with that once. A misconfigured tool just hammering a switch filled gigabytes of logs in hours.
Mm.
So to combat that specific issue, features like the Suppress SNMP Authentication Failure Timer came along.
Ah, okay. What does that do?
It basically tells the device, look, if you get a bunch of failed SNMP logins from the same IP address, stop logging every single failure after a certain point. It suppresses the messages for a set interval, usually 5 minutes by default, but you can change it with SYN server log suppress timer value. Keeps your logs cleaner.
So, community strings. They were a start, but clearly their simplicity became a liability, especially as networks got more complex, threats got nastier. I guess there was a real need to rethink SNMP security fundamentally. How did that play out?
That's exactly the trajectory. The weaknesses of community strings really pushed the need for a major overhaul, which led us to SNMP v3.
The current standard, pretty much.
Yes, SNMP v3 brought a huge leap forward with its user-based security model, or USM. It's defined in several RFCs, 2570 through 2575. USM directly tackles the big security threats that V1 and V2 just couldn't handle effectively.
Like what specifically?
Things like modification of information in transit, someone pretending to be an authorized manager, masquerading, messing with the message stream itself, or just plain reading sensitive data.
Okay.
So unlike those simple community strings, SNMP3's USM uses proper authentication think protocols like MD5, or better yet, SHA variants like SHA-24, and crucially, it adds privacy, actual encryption of the data using protocols like DES or preferably AES.
Right, so authentication and privacy.
Exactly.
Yeah.
Plus, SNMPv3 introduced the View-Based Access Control Mechanism, VACM. This gives you even finer control. With VACM, you can define exactly which parts of the MIB a specific SNMP user or group is allowed to see or change, down to individual objects, potentially.
So if you're managing a network today, you've got V1, V2, V3, different security models. What's the biggest practical takeaway, the must-do for securing SNMP?
That's a great question. And the biggest mistake we still sometimes see is people sticking with SNMP v1 or v2 using just those basic community strings.
Because it's easy.
Maybe easier to set up initially, but it's just asking for trouble. No real authentication, no encryption. The answer, really, is SNMP v3, using its USM and VACM. For secure modern network management, you really need to understand and implement v3. It's not just about getting any data, it's about getting the right data, knowing it hasn't been tampered with, and keeping it confidential. That protects your whole operation.
Right. And just practically setting up SNMP v3 on, say, a RECQS device involves a few steps, doesn't it? Changing the default engine ID, defining groups, defining users with their specific auth and priv settings.
Correct. You set up groups, then users within those groups, assigning authentication passwords and privacy passwords.
And a helpful check those passwords for users and groups, they show up as encrypted in the running config, right? So you can visually confirm they're protected.
Yes, that's a key indicator that you've configured it correctly and the sensitive parts are obscured.
Okay, so far we've talked about asking devices for information, pulling data. But imagine if your network could, I don't know, proactively tell you when something's wrong without you even asking. That's where SNMP traps come in, isn't it? It's like the network yelling, hey, look over here, something just happened.
Precisely. SNMP traps are exactly that, proactive notifications. Instead of your management station constantly polling, asking, are you okay? Are you okay? The device itself sends an asynchronous message, a trap, directly to a designated trap receiver.
Which is usually your main SNMP management system.
Typically, yes, your network management system, NMS. Now, on Rochenki's devices, trap generation is actually enabled by default for all possible traps.
Oh, okay. That's important to know.
It is. But you also have the control to selectively disable individual traps if they're just generating too much noise for your environment.
How do you tell it where to send the traps?
You configure trap receivers or hosts. You need to specify the IP address, IPv4, IPv6 are supported, usually a port number, and then you link it to security credentials. So a community string for V1E2 traps or a security name for V3 traps.
Got an example?
Sure, a command might look something like SNMP server host 10.2.2.2 my public port 200. That tells it to send traps to 10.2.2.2 using the community string my public on port 200. The 0 often relates to version or retries, depending on the syntax.
Okay.
And you can even specify which interface the traps should originate from, like Management Source Interface Ethernet 111 Protocol SNMP. Ensures they always come from a known trusted source IP.
That proactive alerting sounds great. But what about network changes? Big updates, maintenance windows, times when things are expected to flap up and down. You wouldn't want a massive flood of link up down traps or cold start messages hitting your console, right? That would just overwhelm people.
That is a very real, practical concern. And that's exactly why the SNMP trap hold down time
It's
exists.
downtime.
Yeah, its purpose is to prevent that overwhelming flood of certain traps, specifically cold start or warm start traps, during events like Layer 2 or Layer 3 convergence when lots of interfaces might bounce around temporarily.
So it waits a bit.
Exactly.
Hmm.
By default, there's often a 1-minute hold down. The device waits that long after certain startup events before sending the trap. It gives things a chance to settle. And you can configure this time, say, send server enabled traps hold down time, 30 sets it to 30 seconds. It's like telling the network, okay, take a breath before you yell.
Makes sense. So what kinds of things actually cause these traps? Give us some examples of what the network might be trying to flag.
Well, the list is pretty extensive, often grouped by network layer. Layer 2 traps, for example, cover critical hardware things like SNMP authentication failures, power supply problems, fan failures,
Hardware alerts, mostly.
and also operational things like a device rebooting, cold start or warm start, links going up or down, changes in the spanning tree topology, bridge topology change, or even security events like locked address violations.
Okay, and layer 3?
Layer 3 traps generally include all the Layer 2 ones, plus specific routing protocol events. Things related to BGP, OSPF, VRRP, VRRPE, changes in neighbor status, routing table issues, that kind of thing.
And you can turn specific ones off if they're too chatty.
Yep. Just like you enable trap hosts, you can disable specific traps. For instance, no SEMP server enable traps link down would stop it sending a trap every single time a link goes down, which might be too much in some dynamic environments.
Now here's something that sounds particularly insightful. The MAC notification trap. This seems like it goes way beyond just basic health checks. What's the deal with that?
Oh, it absolutely does. SNMP, MAC Notification Trap Support, is a really powerful feature, leveraging SNMP v3. It sends traps to your manager whenever MXC addresses are learned, added, removed, deleted, or importantly, moved from one port to another on a device.
Moved. So if someone unplugs their laptop and plugs it in somewhere else?
Exactly. Or if a device appears on a port it shouldn't be on. What's really transformative here is how it shifts your security thinking.
How so?
It makes it truly proactive. Imagine some rogue device gets plugged in, maybe a user's smart speaker, or worse, a compromised device.
Yeah.
Before, you might not know until it causes a problem. With MP notification traps, bang, you get an alert the moment that new MSC address is learned on an access port.
Like an early warning system for unauthorized devices?
Precisely. It's like having security cameras on every single access port, telling you instantly when something unexpected connects or moves. Now, there are some important caveats.
Okay, limitations.
Yeah, requirements and limitations. It's usually only supported on access ports, not trunk ports. You absolutely need to make sure your network is loop-free. Otherwise, a MAC-C flapping could cause a trap storm. There's often a system limit on the number of MAC-Cs it can track, maybe around 800 or so. And it might not be supported on advanced link aggregation like multi-chassis trunking, MCT.
Okay, so you need to be aware of those.
Definitely. And there's buffer management for the events. Defaults might be around 4,000 events, configurable higher, plus configurable notification intervals, say default 3 seconds, to control how often traps are sent if there are many changes, maybe bundling up to 5 events per trap message.
And the events themselves, like ADD, remove.
Yeah, specific events like ADD MAC, remove MAC, and MAC move, each with details about the MSC address and the port involved.
Wow. So this really isn't just about monitoring anymore, is it? This sounds like network forensics, proactive security.
Yeah.
Finding things before they become big problems.
You've absolutely nailed it. The potential shift to proactive security is huge.
What are the main challenges in actually using this effectively, besides the limitations you mentioned?
Well, tuning is key. You need to configure those intervals and potentially filter traps so you're not overwhelmed by alerts from expected changes, like during normal user activity. Understanding what's baseline normal for your network is crucial. But yeah, by leveraging these traps effectively, you gain this incredible visibility into who and what is connecting. It can fundamentally change your security posture.
Okay, we've covered the what and the how basic access security evolution traps. Let's quickly touch on some finer points that make SNMP really flexible, more granular control.
Absolutely. A couple of important details. One is the SNMP if index. It's basically a unique number and identifier for every single network interface or logical port on a device.
Like a permanent ID for each port.
Exactly. So when you query, you're asking about if index 10101, not just port 111. It's persistent and unique across the device. Gives you very precise targeting. A single module might have up to 64 if index values, showing the granularity.
Okay. And views. You mentioned views earlier with community strings.
Right. Defining SNMP views is critical for access control, especially with SNMP v3. The key concept is MIB objects are automatically excluded from any view unless you explicitly include them.
Default deny.
Pretty much. It means you have to consciously decide what information a specific SNMP user or group is allowed to see. You build views by including specific MIB branches or objects. For example, SNMP server view main system included creates a view called mains that only allows access to objects under the system branch of the MIB. Nothing else unless you add more included statements. Very granular.
Makes sense. Now, networks are always changing. IPv6 is obviously huge. How does SNMP handle that? Is it future-proof?
It is, yes. There's full IPv6 support for SNMP. You can define IPv6 addresses as trapped destinations, hosts, and you can use IPv6 addresses in your access control lists to restrict who can query the device via SNMP. So it's ready for modern networks and the transition away from IPv4.
Good to know. Okay, last technical bit. What happens if an SNMP v3 request just fails? You set it all up, you think it's right, but the query gets rejected. How do you figure out why?
Yeah, that can be frustrating.
Right.
But SNMPD3 actually helps you here. It's about interpreting varbins in report packets.
Arbines.
Variables bound to data. When an SNMP v3 agent rejects a request, it often sends back a special report packet. And inside that packet, it includes specific varbins that contain error codes or status information explaining the failure.
So it tells you what went wrong.
It tries to, yes. The source materials list several common reasons you might see in these varbins. Maybe unknown packet data unit, unsupported security level, like requesting encryption when only authentication is configured, not in time packet, clock skew issue, unknown username, wrong digest, authentication failure, or decryption error, privacy password mismatch.
Okay.
So what's fascinating here is that even when it fails, SNMPv3 gives you these diagnostic clues. It turns a dead end into a troubleshooting path.
These little detailed messages are almost like breadcrumbs, aren't they? Leading you right to where the problem might be. Instead of just error, you get wrong digest. That's way more helpful.
Immensely helpful for administrators. Absolutely. Saves a lot of guesswork.
Wow. Okay. So from its, well, pretty humble beginnings with those simple community strings, all the way up to this robust, secure, really granular SNMP v3 we have today, this deep dive really shows SNMP is way more than just a simple monitoring tool.
It really is. It's become a cornerstone of modern network management.
Yeah, the key takeaways for me are really about thinking proactively about security, using the detailed diagnostics it offers, and just gaining that much deeper understanding of what's actually happening inside your network.
Exactly. The evolution, especially with USM, VACM, and those clever features like AMAC notification traps, they give you the tools you need for that comprehensive insight and control.
So, here's something to think about. If your network could constantly tell you its secrets, its struggles, its successes, everything, how much more effectively could you manage it? How much more secure could it really be? SNMP gives your network that voice. The real question is, are you truly listening? And maybe more importantly, are you configuring it to speak clearly, securely, and in a way that actually empowers you?